Expedia is a big company. We're not here representing all of Expedia with this particular presentation. This is something, we're going to present some things that some of the two teams within my organization have done in terms of integrating and innovating using AppDynamics. So in particular, we are part of what's known at Expedia as the eCommerce platform organization. And within the eCommerce platform, you can think of those as the systems and services that facilitate and orchestrate the purchasing process, right? So we don't do the shopping stuff. We don't have the technology that allows you to find the hotel or find the flight. But when you're ready to book that thing, then you start to use our system. So our primary workhorse system is what we call the ordering system or the order management system. And it does the hard work for facilitating and orchestrating the purchasing process end to end. So we integrate with the inventory systems, we integrate with our payment systems, we integrate with the financial systems to make sure everything is kosher in order for your order to be completed. We also own the financial systems, own and operate the financial systems at the company, and which we track and record all the money associated with those purchases. And just given the way that Expedia is structured, so some of you may think of Expedia as Expedia.com, but actually when I speak of Expedia, I talk about Expedia Inc., Incorporated. And that is an umbrella corporation, if you will, for many different travel businesses. So underneath that is Expedia.com or Expedia.star in other countries, but we also own and operate these businesses. So we, the e-commerce platform, facilitate the purchasing for all of these different travel websites. Hotels, Hotwire, Hotels.com, Hotwire, Venere, what are some you may know? Travelocity, Agencia for corporate travel, and the most recent acquisition is Orbitz. And so as the e-commerce platform, whenever you place your order on any of these sites, they all flow through our system, our platform. Serving so many different businesses presents some very interesting scalability challenges for us. So there are many different systems that we need to integrate with in order to do this. There are many different business models for this. The Hotels.com is very, very different from Agencia, which is corporate travel. There are many different customers, both internal and external, that we need to be aware of and accommodate in the way that we operate these systems. And there are many different operational support needs. So each business unit may have different operational support needs. The teams within the e-commerce platform have different operational support needs, and we best effort to accommodate all of them. So it's very critical for us to be able to scale up our operations. And one way that you can scale up anything, in particular operations, is to simplify. Simplify as much as you can wherever you can. And so two of the things that we've done in my organization, we've looked to simplify how we troubleshoot issues, because bad things are going to happen. So we're looking to simplify how we troubleshoot and identify and get to root cause of those issues so that we can mitigate those as quickly as possible for our customers. And we look to simplify our operational tasks via automation. So you're going to hear sort of a two-part presentation today about two different things that we've done to simplify and scale our operations, right? And so I'm going to turn it over to Badri. I have two engineers who are going to do most of the talking, I guess second after I do most of the talking. First, I'm going to introduce Vishal Singla. He's here. He's one of my SDEs that led the effort for some of what you're going to hear today, and he'll come up for a question and answer because he'll keep Badri and I honest with all the actual details. And then to my left is Badri Govindarajan, who's going to go through the presentation for you. There you go. Thank you.
Thanks, Tino. Good afternoon, everybody. My name is Badri Govindarajan. I'm a senior applications engineer in transaction operations team. We started using AppDynamics 3 years back. We have pretty much we support around 80 applications, 70 to 80 applications. We have instrumented almost 75% of our applications, of our business transactions. operational issue. Okay. So today for our agenda, I'll give a brief background on what happens when you click on the book button in any one of our sites. And then we'll give you 2 use cases on how we use REST API. One is for how do we automatically generate transaction snapshot at our will. The second one is how do we automate health rule creations. First, what happens when you click on the book button? Expedia is a very complex distributed system. It has multiple data centers. We have data centers across the world. We have several teams, several practices, several development practices, several operational engineering teams. To be honest, I have not even met half of them yet in Expedia in the last 3 years. I just know during a war room, I just meet some people. I have not met all of them yet. So we use several technologies. We are encouraged to use several technologies. We learn, we test, and then we fail fast. We use several platforms, several technologies. We have web services talking to each other. We have several messaging solutions. You think of a technology, there is some team in Expedia that is using it or learning to use it. We have several SQL solutions, Cassandra solutions, Mongo solutions, and there are always operational burdens that come along when you try these systems. So here's what happens when you click on the book button. This is a snapshot that was taken last week when we tried to take a snapshot of one hotel booking. So it has to pass through 37 distributed web services. This web services can be order inventory systems, fraud detection systems, payment systems, third-party payment providers that live outside Expedia's data center. We have several databases. We pass through, for a single booking, we pass through 56 databases, some SQL Server databases, some Cassandra databases, Mongo databases. We have several messaging queues. We have Kafka, we have RabbitMQ. It has to pass through all those things. And then we have caching systems. So for the first, what's that? So the first one, how do we are looking at AppDynamics. We have been using AppDynamics for the last 3 years. We are trying to learn, and we have adopted it quite well now. So in the last 1 year, we have been trying to use AppDynamics REST API and try to see how we can automate our operational burden on. The first one is how do we get automatic transaction snapshot. So AppDynamics creates transaction snapshots, but we wanted to use the feature where we can create transaction snapshot at our own pace, instead of relying on AppDynamics to give us transaction snapshot, because AppDynamics uses a general algorithm to give transaction snapshot, which is sometimes very difficult to identify problem. So we started using REST API for that. Before I deep dive into this problem, I would like to give you a scenario on how we are using this in a development environment. Here is a usual scenario. We have a frustrated customer. He's booked a ticket in Expedia.com, and he wants to make some changes. He logs into Expedia.com. He tries to change his hotel, or he tries to change his flight. He's not able to change. He gets an error message. He doesn't know what to do. He's in a hurry. He's frustrated. So he calls the customer representative. The customer representative gets all the information. He greets him, the usual hello, hello. He greets him. He takes the order number. He searches through his system, and even he's not able to find it. There is an error. He apologizes to the customer. He tells him he'll get back to him. So the customer goes away. Now, as a regular, the customer agent now follows the regular protocol. He engages our tier 1 support. The tier 1 support, what they follow our runbook. They see what this error is, what the error code is. They try to engage the right team. It usually happens that they don't get the right audience. what happens? They start creating tickets. They engage several different teams. So the way it begins. First they create an incident ticket that goes to an application engineering team. The application engineering team, if it's not possible to find what the thing is, they create a team, they find out the problem might be related to an ordering team, so they create a ticket to them for a troubleshooting. Ordering team, they might not be able to find the information, they try to pass along the bug to somebody else. And then it keeps on going. So and then it keeps on happening, and at this time, we have a very dissatisfied customer. He might not even return back to Expedia. He had had a very bad experience. Our response time for solving this particular issue is very high. It increases with every ticket we create. And we have only started now creating tickets, and now as soon as we identify the right team that owns this problem, we have to find out the root cause of the problem and try to fix this. That all adds to the time. So possible solutions, how do we fix this problem? We looked at several possible solutions. One is grow the team. We hire more people. Every time I go to my boss, tell him we need a headcount, my boss goes deaf. He doesn't even want to talk about any headcount increase. And it is also not very cost effective. The next solution we have is somehow find out a common identifier between all the transactions in Expedia.com. I was talking to our Splunk admin yesterday and asked him how much log do we write. He told me on a single particular day, we write 40 terabyte of log. So now, to read this 40 terabyte of log, it's going to be difficult to find out that single transaction when it happens. And we have to exactly identify how the user clicked the button, what all he did do. We don't get all the information that we have. Like a representative might give some information that he understood. He might pass along some information to our tier 1 support, then information get cut along as he creates the ticket. So passing through all this 40 terabyte log is also not that optimal. Then we started looking into, we already had AppDynamics on almost all our systems. So we started looking into AppDynamics to see how it can solve our problems. Then we learned about transaction snapshots. When we looked into solution, we were very clear on this. We wanted the solution to be very, very simple. Things we are looking for in the solution is, we don't want to start telling teams to write one more log file. We don't want to ingest that into Splunk again. We don't want to write one more log parser to have that log ingested. And then we want to see the problem. Instead of just reading the logs, we want to see what the problem is. That would give us not only an engineer, but also a customer representative. He can easily see the problem and what the problem is. What's the transaction snapshot? AppDynamics uses transaction snapshot for everything. It's a visual representation of how your transaction flows through the system. It gives you a lot of diagnostic data. It gives you code level visibility. I've seen it's been very helpful. Sometimes I could easily see line number 10 on your code has said it's taken a long time. It's breached the SLA. So here's our design workflow, how our solution works. A developer configures a data collector. A data collector it's an easy way of identifying a transaction. He configures a data collector in our AppDynamics admin page, and this is pushed to all our cloud, in the backend it is pushed to AppDynamics cloud, and that is pushed to all our Expedia servers. Now, an agent or a developer who is trying to identify an issue, he logs into our internal booking search tool. When he logs into the tool, he injects this data collector code into his search. Here is a code snapshot on how he does that. He basically inserts into the header, saying that he is so-and-so person, and he wants to tag this particular transaction with these details. And then he makes a search through using our system. The transaction goes through our system, and it presents him with the transaction snapshot URL. Now, when you click on this transaction snapshot URL, it gives you directly the transaction snapshot. You would be able to see the entire transaction flowchart and how it passed through all the systems. This is all done using REST API. how we generate this URL, everything comes out of the REST API. I would like to give you a slide demo on this. So here is our internal booking search tool that we use for searching for doing a search on booking. So the customer who called us gave us an order number, so we use that order number to put in there, and we try to execute this order. It gives us this page with this URL. And when an agent or a developer clicks on this URL, he directly lands in this snapshot. And this snapshot, the one that is circled here, tells him exactly where the problem is. Instead of, usually what happens is, when the tier 1 support engages, they usually create ticket. This is our entry application. He usually creates a ticket here, and then it passes along to anyone of the system. But now with this feature, we can directly say, hey, there is a problem here. Let's deep dive into this problem. When he deep dives into this problem, he could exactly get what the problem is. Here it can be a database call that is very slow or something wrong with the database. Right, and more diagnostic information about this particular code. So what went wrong here? We made several mistakes here. One is, we could have easily prevented this. The next one is our resolution time. We kept creating tickets. Another thing is, we used customer as a tester. Instead of, it's very bad that customer notified us about this problem. Then we started looking into how do we be more proactive about this than being reactive about this. Then we started looking about how do we create alerts and monitors using REST API health rules. So we wanted to be more proactive and stop being reactive. The first solution is more kind of reactive. The second one is it helps us to be more proactive. Before I say about the solution, I would like to give some details about what are all the operational problems that we face. Here are our common problems that we face in our team every day. There is some server always crashing on some data center. And then there are several servers that are hanging. It's slow. There are latency problems across multiple data centers, unknown errors, unknown exceptions. We have garbage collection issues, disk I/O issues, network I/O issues. Traffic patterns, there is a sudden increase in traffic. There is a bot running somewhere that is causing spike in traffic that causes latencies. All this leads to an unhappy customer, which finally results in financial losses. So as an operational engineer, I want to be very efficient. My team needs to be very efficient. That would result in a customer delight or customer satisfaction. We wanted to have very effective monitors. We wanted to reduce noise we don't want false alerts. We want to be very, very predictive. If server A goes bad, we usually know the server B is going to go bad in next 6-7 hours. We want to detect problems very early, and we want to restore them very quickly. And we want to, wherever possible, implement auto recovery. We want to catch very small problems at the initial stages before they become big or before they become an outage. So 3 years back, when we released AppDynamics, there was this, we learned about creating alerts manually in AppDynamics. So our mission was, everybody in the team, take 10 services, go create alerts. So we defined that every system should have at least 10 alerts. 10 alerts all systems should have, and everybody went and created alerts. Over a period of time, we did not do that properly. We found out, last year we had an audit, and we failed miserably in that audit. So we learned that it's very time-consuming creating alerts. As time progresses, our standards drop. We don't, our work priority changes. We forget to create alerts. All those things happen. And last year we just wanted a list. Actually, our auditors, they just asked us, can you provide us the list of alerts that you have in your system? We tried to get that. We had several documentation in alerts. So documentation would say alert is enabled. If you log into Splunk or if you log into AppD, that particular alert might be disabled. So it's always a problem to keep in track which are enabled and which are disabled. So we found out this creating alerts manually or creating health rules manually is not a very highly scalable solution. So then we looked into AppDynamics REST API for this. Here what we did, instead of we created templates. In our AppDynamics controller, what we did is we created templates for each of the alerts that we want. These are some samples of our templates. So all these are templates, so they're disabled. Here is a sample of a template on how we have configured a template. Just a walkthrough of the AppDynamics health rule template. So this one is for a mission availability template. So here we say, okay, this is for a mission availability template. We say that this particular application, if it goes below 10 servers, send an alert. So we save this templates. The next thing we did is we integrated with Jira. So every time somebody enables or disables, anybody who goes enables or disables in Jira, there's a poller that runs across AppDynamics controller. It keeps looking for changes in alerts, and it will update Jira accordingly. We also use Jira as our alert documentation. So the Jira ID will be our alert ID. So if monitor 1, 2, 3, 4 fires, everybody knows the documentation for that particular alert is monitor 1, 2, 3, 4. They just log into Jira, browse through the ticket, and there will be specific instruction for each team. Tier 1 support, what do they need to do? Tier 2 support, what do they need to do? And what is the escalation procedure? What servers are affected? What downstream are affected? Is it causing a booking impact? All those information will be there. This documentation will enable our tier 1 support to know the priority of this alert, how fast they want to react to this alert. Then we also integrated with a Jenkins job to make it very easy for everybody to use this feature. So how it works, you log into Jenkins, you download the template. There is a job, it basically downloads the template. It replaces tier, it replaces the default monitoring thresholds. It uploads back to the controller, and it creates the policies for those alerts. So here is our Jenkins job snapshot. The first one is the service name or the tier name. This we get it directly from AppDynamics controller using the REST API. Here are all our service running, and the number here says how many number of servers are there for that particular service. This is directly coming from the REST API. So we don't do any kind of maintenance on this Jenkins job. So every time you delete something on the controller, it automatically gets populated here as well. The next one is what kind of alerts do we support? If for an application, if an application doesn't want any of this, they have the choice to remove them. Next one is we want to use our existing Jiras that we have already created for some alerts, or we want to create new alerts, new tickets. Next one is we want to have a feature where we can say, okay, the template comes with the default threshold. We give here an option to change that threshold. Because all applications, one shoe doesn't fit all, so we give this option to, if they want to change, they can go ahead and change it here. Now here is a full workflow on how it works. Either a user or a Jira, you either create a Jira to invoke this entire workflow, or you have a person who's invoking this job. He invokes a job. The job basically downloads the template. Then it changes all the parameters that the Jira has or the user puts in. It uploads back to the controller. The controller pushes it to the cloud, and it gets to the Expedia data centers. And then it's monitored every time based on those health rules. And every time there is a health rule violation, there is an SNMP alert that is fired. So here is a result of how a template got changed into an actual monitor. So here is our template. And then after all the processing, we get a monitor with the same exact name. Our app got replaced with an actual application. And then this particular alert was sent to our tier 1 support, so it had an _knock in the end. So what did we gain using this? On the first day when we started using this in production, we created all our 600 health rules across 70 applications with just one button click in 2 hours. We just click the button and it just flowed through the system. There was nobody even monitoring it. And then we have a very standardized configuration. This was very important. Like when we learned after 2 years of creating alerts manually, we found out that in AppD there are several ways you can configure an alert, and each one has its own disadvantage or advantage. We wanted a very standardized configuration. So when we want to change, we change it all in one place. And then our overall time for resolution decreased. We have also reduced the cost of maintaining these alerts now. One main thing we have now is we can enable or disable an alert programmatically. So when we are doing server patches or when we are doing some kind of maintenance, we are able to use the same Jenkins job, or during our deployment, we use this same API to disable these alerts. So thereby we reduce noise also. Some key takeaways: we are now able to visualize the problem rather than reading log files after log files. Now we are able to really visualize problems, and this helps us at rapid troubleshooting. We can easily diagnose problems. We know exactly where the problem is. It's very easy to implement. If you already have AppDynamics instrumented, this becomes very, very easy. In fact, health rule automation, it took us like less than an hour to actually get the initial setup up and running. And then this solution is scalable. We are trying to now we rolled out for our basic alerts now. In coming months, we are trying to roll out for our business transactions, calls per minutes, latencies. We are trying to roll out for all of them using the same set of jobs. We are also using it for database monitoring, backend monitoring, business transaction monitoring. Here are some useful links that we found very useful in AppDynamics for enabling this feature. And I turn up for questions now.
Go back to that last slide. So I have a question on your snapshots.
Yes.
So it looked like in the example that you gave with the screenshots that you went back and typed in an order number, and doing that would give you a URL to a snapshot. Does that mean that you're creating snapshots for every single transaction? How do you get that one-to-one relationship between a snapshot and your order?
Actually,
It's okay. It's on.
okay. So basically, you can configure the data collector based on your needs in terms of whether you want to capture all the transactions or a one specific for which you want to test out. In the example which we have it in demo, that order we want to capture it only for that particular transaction. So application is instrumented to inject the header for that particular order.
But you're doing that for every transaction of that type?
For that, yes, from the tool. Yeah, but it's optional. You can tweak.
Right, I understand.
Yeah.
Did everyone on this side hear the question? No? Can you repeat the question?
The question was, does it capture the transaction for like the snapshot for every business transaction or for something specific? And the answer was it depends. Whether the tool can be configured to capture any business transaction versus a specific. So.
Let's say you have configured it. I'm sure you won't configure it to capture every business transaction.
In production, probably not. Yeah.
This particular order was going through your system, and then you know there was a problem after the fact. So how did you get the URL for that particular transaction snapshot after the fact?
So the tool which we had is to basically run through the scenario what customer has experienced, and by searching an order or changing an order, we are running through the same business transaction. And the way we are getting the URL is basically first we are letting AppDynamics know that capture the snapshot for this particular business transaction, which is issued from the tool. And what we do is basically we generate a random GUID, which is basically a key or identifier in the AppDynamics REST API being used to capture the request GUID. And that's how we construct the URL, so that a person doesn't have to go to the AppDynamics admin page to figure out based on the timestamps. They can directly click on the link and they basically see the business workflow.
It does not have to. You don't have to give the repro steps now. The repro step is in the transaction snapshot.
Does that answer?
Yes.
For business transaction, do you monitoring all your business, or let's say you have 20 order, 100 order today, you see how many percentage fail, or it's all successful, or something like that? Or how do you handle it?
You can configure the business transaction monitoring based on various parameters, like if the latency goes X amount of time, capture all the snapshots at that point in time. So AppDynamic controller has options for you to configure based on the needs, whether you want to do it on the need basis versus for a certain threshold kind of thing.
Can you repeat the question? Snapshot, you can't be monitoring everything. My situation, let's say our business partner send us 10 invoices. I want to monitor it. The 10 invoices has been go through, everything's successful. Or it tells me what failed, why it's failed. Something like that situation.
This solution will not be helpful for every single transaction that you use. It will be more useful when you want to address one peculiar problem you have. So it's not intended for all the transactions. In fact, I was talking to AppDynamics engineers yesterday. They were telling me if you send more than 100 transaction snapshot request, they start throttling it. So this is not for every single transaction.
Maybe using AppDynamics, it's overkill. Monitoring all business transactions.
So there is two things, right? AppDynamics by default monitors every single transaction, right? But what we are doing is we are forcing few business transactions to be, we are like ad hoc, we are trying to take few transaction snapshots. That's what this feature does.
And I'm not sure if the question can be heard on the other side of the room. So the question, what I'm getting is, do I have to capture snapshots for everything? Can I be selective about the things that I capture snapshots for, maybe only for failure cases, not all of the success cases? Or can I, how much freedom do I have in that? Is that the essence of the question? Yeah. Okay. AppDynamics gives you the ability to say which transactions you want to capture these snapshots for. We're saying you probably don't want to do it for everything. Well, if your traffic is low and your system is not extremely complex, there's only a few components, capture for everything. You're not going to run into any limitations. But if you have a very high throughput in a very complex system, you're probably going to hit, capturing a snapshot takes resources. It takes time, they have to save it somewhere, so it's taking up space somewhere, right? There is a natural limit that AppDynamics can handle. That natural limit may be dependent on your implementation, your controllers, and your software, a combination of those things. So I don't know if we don't have like one specific number that will work for everyone, what that limit is. You have to sort of figure that out on your own. For our implementation, we did, we have choosy enablement, I guess, right? We can select when we want to enable capturing a snapshot. We don't capture for everything, but when we get a sense that there's a problem going on in a particular space or with a particular type of transaction, we can go and turn it on to get the diagnostic information we need to troubleshoot and to resolve the issue.
Can you turn on the other header that you inject when you create a transaction, right?
Right.
Yes.
We turn it on via the header that you inject. So all of these services are, and maybe it goes without saying, but I'll just say it just to make sure it's explicit. These are our HTTP web services that we're talking about. The interaction between those green circles on that diagram is all over HTTP. So we are leveraging AppDynamics feature that allows you to inject HTTP headers into the payload that just stays there as long as these services are communicating. That header, as long as it's present, AppDynamics can track it and give you diagnostic data all along the way for each hop.
And the beauty of it is that you're all, let's say for example, you have 50 services, you want to be capturing a snapshot. You don't have to instrument 50 services to inject that header. AppDynamic behind the scene automatically pass on that random GUID to all its agent and connect it and wire it as a single business transaction. So only the head, top on the head, you just basically inject that header and it's propagated to all the way downstream.
As long as you have the agents already configured to work with that particular application.
Yeah,
In the back?
yes.
So you guys said you're doing 40 terabytes of log data a day. What's your AppDynamics data store size?
What is our AppDynamics?
This is the data store size for AppDynamics. Just wondering scale-wise. You're doing 40 terabytes of logging.
For,
I
we
think
send it to AppDynamics Cloud. Maybe
Okay. So you did no
we don't have visibility on what happens on the other side.
Yeah.
We have visibility on the Splunk side, but not on the AppD side.
Yeah. We're more of the, our group, there's a different group at Expedia that manages our AppDynamics setup. So they would have an answer for that. We don't. We're just users and we stuff a bunch in.
Just
And
interested in scale.
yeah, we just keep throwing stuff in until they tell us to stop.
Yeah, we have a default policy now. If an application wants to be in production, first thing we do is enable AppD. Whether we instrument it or not, we make sure that we have a machine agent and an app agent running always.
Yes.
Right
Yes.
there.
So for the
Repeat the question.
go a little bit more in depth. So are you sort of predicting, you gave a scenario like, hey, you got a customer that's had bad experience and the data there available so you can troubleshoot a little bit better. So within the system, are you doing some sort of additional analytics to see like, oh, this customer is going to have a bad experience going bad, so let's start the snapshot for them? Or is it just you configured it to, specifically configured it to grab X amount and you're hoping that for that bad, like that bad experience, for that set of customers, you're hoping that transaction snapshot will try out?
Is that more, if I understood correctly, is that are you looking for how could it have been more proactive than the reactive part where we have the customer going through the bad experience versus we all somehow identifies and
Sort of like if the question to people, and it's kind of my mind, if I'm not capturing every single transaction, how are you able to capture the data for that one customer who's having a bad experience? Are you doing sort of analytics as the customer is going that is predicting this customer is having a bad experience?
Oh.
Therefore, we start to
No.
snapshot to capture that information?
Now, at this point, we already know which customer has the problem. At this point, we are very reactive. We know which customer is having problem. We know exactly all the information that we need before we start using this tool.
Yeah.
There is no prediction at this point.
When did you turn it on?
So say, for example, you're the customer. You complain about it. You give all the details. Then I'm the ops engineer who's looking at your problem. I go turn it on at the time, and I do the exact same steps that you might do on the website. Yeah. So at that point, I will, instead of asking you like, what all did you do on the site, now I can do that myself.
This basically drastically reduced the turnaround time of so that we don't have to create 10 tickets to reach to the root cause, visualize.
we were using SCOM a lot, and then Splunk. Those were the two we were using a lot. But SCOM, creating management packs for SCOM every time for every service was difficult.
Were you actually using the APM tools inside SCOM or just the traditional monitoring?
Traditional monitoring tools.
The question was, what else did we evaluate? Why do we have AppDynamics? What other APM solutions did we evaluate? How did we decide that AppDynamics could do some of these things that we presented and add more value? And the answer was, well, before AppDynamics, we used some other things, primarily for monitoring, though. The SCOM and the Splunk, we use for monitoring and log aggregation in Splunk. AppDynamics is a much, has a richer feature set for application performance monitoring. That decision predated a lot of us, though. So it was, for myself, it was there when I showed up, so I used it.
Are you still using Splunk for your logs, or are you still using AppDynamics?
Repeat the question.
Are we still using Splunk for our logs? Yes, we still use Splunk for our logs. So I wouldn't say like AppDynamics is replacing Splunk. It's kind of both coexist. We use Splunk for certain things. We have not turned on TP99 measurements in our AppDynamics for performance issues. So we use Splunk for those kind of things. And we use AppDynamics for system internals.
Okay, well, thank you.
Thank
Glad
you.
the roof didn't fall in on you all.